Hello, this is mathema again. Today we are going to talk about circular permutations, but with conditions. So I have here a problem context. It says here, 10 diplomats from the following countries are to be seated around a circular table for a summit meeting. We have set A, allies of US. We have US, UK, Japan, Australia, Philippines. Set B, allies of China, China itself, Russia, Pakistan, North Korea, Iran. So we are asked to compute the number of distinct seating arrangement under each condition. So we have case 1. There are no restrictions on seating. So this is a circular table. So when we talk about circular permutation, you're just gonna make use of the formula n minus 1 factorial. Since we have 10 diplomats, so this is now 10 minus 1 factorial. This gives us 9, right? 9 factorial, or what is 9 factorial? Let me just grab the calculator. This is 9 factorial. That gives us 362, 880. So this is 362, 880 ways. Number 2. All diplomats from set A sit together as one group, and all diplomats of set B sit together as one group. So again, if we have this our circular table, we will have two groups, right? This is set A and this is set B. All right. So how are we going to answer this question? So we are going to treat set A as one block, and again set B as one block. So we have two blocks together. And then how many ways can we arrange this one in a circular table? There are n minus 1 factorial ways, right? So this is just n minus 1, that is 2 minus 1 factorial, or simply 1 factorial, or simply 1. So we can arrange this particular two blocks in one way. Now, in each block, we can actually rearrange these 5 people here 5 factorial ways, right? So since again there are 5 peoples inside this block, so we can rearrange them 5 factorial ways, or that is just 120. But not only that, this also. So we have another 5 factorial ways, that's 120. So this is just 1 times 120 squared, or this will give us that's 14,000, 144. So that's 14,400. Let me see. 120 squared, that's 14,400. All right, 14,400. So there will be 14,400 ways to arrange this 10 diplomats. Let's do case 3. The condition is the following diplomats must sit together. So we have US, UK, Japan, Australia, China, Russia, Pakistan, North Korea, Philippines, and Iran. So again, they are now in pairs. So we have 1, 2, 3, 4, 5 pairs. So in our circular table, instead of doing 10, we will now have 5 pairs. 1, 2, 3, 4, 5. So how many ways can we arrange these 5 pairs in our circular table? Again, there will be n minus 1 factorial ways. So this is 5 minus 1 factorial. This is 4 factorial. Now, each pair actually can rearrange themselves, right? Again, each pair, this pair, they can actually rearrange themselves or arrange themselves 2 ways. This is 2 factorial. This is also 2 factorial. 2 factorial, 2 factorial, and 2 factorial. We have 5 2 factorial ways to arrange everyone in the circular table. So what we're going to do is we're going to say we have 4 factorial times 2 factorial, and then raise it to 5. Because again, there are 5 groups here. And we know that 2 factorial is just 2, and then raise to 5 is 32. So we have 4 factorial times 32. That gives us, say, 4 factorial times factorial times 32. That gives us 768. So this is now 768 ways. Let's do number 4. Diplomats from set A and set B alternate seats. So they are sitting alternately. So if we're going to draw that one, this will become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will become A, B, A, B, A, B, A, B, and of course A and B. Alright, just sitting alternately. Now, what we're going to do here is we're going to treat the set A as one block and set B as one block. So if we have our circular table here, 1, 2, 3, 4, 5. How many ways can we arrange set A in the circular table? So set A, that would be n minus 1 factorial ways, or 4 factorial. And then, if this is our set A here, how many ways can we arrange set B in the circular table? What we're going to do is just fill in the gaps. So this will become our B, 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 and B. So how many ways are there? There will be 5 factorial ways, right? 1, 2, 3, 4, 5. So set B gonna have 5 factorial ways. So this is just 4 factorial times 5 factorial. 4 factorial is 24 times 120. This gives us 24 times 120. That gives us 2880. So this is 2880. Let's do number 5. Two presidents cannot sit together. So for example, China and Philippines cannot sit next to each other. So how are we going to do that? So again, we have our circular table. So in our circular table, again, we have 10 people here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, since China and Philippines cannot sit together, again, if we're going to do this one visually, this is what will happen. We're gonna fix one person. So let's say we can fix this one. So that is just, we have one way to do that, times how many ways can we arrange China or Philippines. For example, we're gonna put say this is China here. So Philippines can be, they cannot sit together, right? So Philippines can be here, 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 or here. So there are 1, 2, 3, 4, 5, 6, 7 ways to do that. So we have times 7, not 7 factorial, but there's 7 ways. And then what are we going to do next? The rest, we have now 2 groups, right? We have now 2 groups. So the rest, we can just arrange them 8 factorial ways. So this is what? This will give us 1 times 7 times 8 factorial, let's say. And that gives us 282,240. Is that correct? So there are 282,240 ways to arrange in such a way that China and Philippines will not sit together.